Welcome to my session on the Event-Driven Microservices Conference 2020, the Exonic Conference. I'm glad to have you here in my session, which I'll be presenting from the comfort of my home office due to the current state that the world is in. It's very unfortunate we cannot meet face to face. But I'm present during the stream. Feel free to ask me any questions in the chat if they come up. So my talk will be about microservices in the telecommunications space. I work for communication service providers, CSPs, and it's an industry that went through a lot of change. It used to be a very innovative industry. Telecommunications changed the world, made it a lot smaller, as you all know, ranging from the first telegraph lines, crossing the oceans into fixed line telephony, into mobile telephony, into fixed line internet, TV. You've all probably been part of that journey or been born halfway through it. The industry is changing, though. CSPs are struggling not struggling to make money, but to monetize their products. They've become a commodity product. In most markets nowadays, you get unlimited rates, unlimited tariffs. There's net neutrality, and we come from an era where the phones used to be unique to a CSP. You pay per use, you'd pay per SMS, you'd pay per call minute. Some still do. But it's all been commoditized, and the market is, I'd not say oversaturated, but it's very hard for them to compete. It's getting harder and harder to compete. They have to differentiate. And it's hard to differentiate in something like a data line. It has a speed, it has a latency, and we consumers, we don't even care that much. But that's it. And then there is a model in which you pay for this, a prepaid, a postpaid, a hybrid of the two. And that's basically it. The phones are open. eSIM made an introduction. It's very easy for you to swap providers these days. So they have to differentiate. They have to be better than the other. And doing that in just the way you pay for it is becoming harder and harder. So they do all kinds of stuff, right? They merge together with other companies. You see a lot of mergers of media and entertainment companies with communication companies. Because they want to provide unique content. That's a differentiator. But one thing they are focusing on a lot is what they call the digital transformation. They all want to become the next Netflix of CSPs. They want to give you the best user experience possible and use that as a differentiator from their competition. And if you look at the landscape of IT systems in a telco, that's a very interesting landscape with a very interesting development over the years. Where of course the early days, mainframes and big IT and everything was built bespoke because there was nothing on the market. Moving into an era where a lot of the software needed to run a telco became available as commercial off the shelf or COTS software. You saw a lot of telcos adopting that. Outsourcing a lot. Outsourcing is huge in telecommunications. And what they used to do is buy a lot of these COT systems. They'd stitch them together. System integrators do that for them. A lot of that outsourced. And that's how they build up their IT landscape. And then they started buying each other or merging with each other, and they ended up with huge, big landscapes of systems. And we are in that space. We do projects in that space. We build products in that space. That's what I do in my daily life. And we've adopted event-driven microservices some time ago. We've been working with specifically CQRS and event sourcing for over 4 years. We have big customers, so they will serve. We're in the sales area. They will serve over 50, 70 plus million customers. We also have smaller ones, of course. So we employ CQRS and event sourcing on quite a large scale in production in business critical systems. And out of that have come a lot of learnings. And that's what I will talk to you about today. So who am I? My name is Pieter Pabst. I work as a product and platform CTU in the CME VBU of Tech Mahindra. That stands for Communications, Multimedia and Entertainment Vertical Business Unit. I also have to get used to all the abbreviations. And I got here through acquisitions. I work on a product these days called Blue Marble. And in the last major version of this product, we've been using CQRS and event sourcing. We do that in projects around the product as well. It's on the market for some time. We have some experience running that at customers, selling that to customers, working on that with customers, operating it. And I'll tell a bit about the journey into all of that and how we got to CQRS and event sourcing and what it brought us in terms of which problems did it solve for us. But I'll also talk about which problems has it introduced. And then I'll try to come up with a conclusion on when should you do it, and if you do it, how should you do it. So I'm not a consultant. I'm not a trainer. I'm not a purist. I'm a very pragmatical guy. I'll approach this high level. There are a lot of great speakers on this event going into all the details, all the patterns, the design considerations, domain-driven design. How do I work with my bounded context, my aggregate routes? I'll touch on those, but I'll not go into a lecture or a training. It's more of an experience story that I'd like to share with you guys today. So what do we do in telecommunications? We need to sell products to customers. That's specifically the area that I focus on a lot. And then when customers buy those products, they need to get support on those products. They often buy both services and physical goods, right? You buy a handset with a subscription, and you'll have problems with that. Your handset will break. You might not like the handset you bought. You have service interruptions. The network is slow. It's not available. Things like these. So there's a lot happening around sales and sales support. And sales seems like a simple thing, right? E-commerce, for example, you have a product catalog somewhere and you expose it. You have a shopping basket. People can add stuff to it and then buy it, pay for it. But in telco, things tend to get complex. We love complexity in the telco world for some reason. Had to do a lot with the fact that differentiators on connectivity are mostly how you pay for it. That has been the case for a long time. So the models, how you can pay for these products, they tend to vary a lot. There are different ways of paying for them. Some are on contract, some are on prepaid, some are hybrid, some work with buckets, some are unlimited. And then there's an entire commercial model behind it, right? So you can buy certain devices with certain services. Because you buy a service, you get a discount on your device. Because you have a certain service, you can buy another service, and that makes it quite complex in terms of a domain. But that also makes it a modeler's dream. I'd say there's so much in this domain to model. You can keep going at it for years and not touch every corner of it. So there's some organizations in my industry which standardize modeling, for example, TM Forum. And that's an interesting aspect when you talk about, for example, domain-driven design as well. How do you deal with industry standards? Like in my case, they actually have API specifications. If you do something like domain-driven design, and those specifications are not coming from a domain-driven design angle. There are a lot of systems that we need to support all of that, and they all have cool abbreviations. We love the three-letter abbreviation in telco, as you can see. So these are some of the areas that I work on. The main thing that I work on is BSS, Business Support Systems. BSS, that's not what you think. Business Support Systems, and in that you have a lot of different types of systems and different combinations. And the main ones are, for example, CRM, Customer Relation Management, ERP, COM. You all know ERP, which is Commercial Order Management, CPQ, Configure Price Quote. We deal with inventories. You have existing products, you have existing services. We need to store them somewhere, and Well, we use them when you want to upgrade, when you want to downgrade, when you want to move your address. We use them to send you a bill. That's also important. And you'll have problems. You'll raise cases. You'll have communication, and there's interaction, and there's all kind of stuff around that going on. Lots of systems that a telco will have, and usually these are big monolithic COTS applications. Are more and more they are also not just on-prem COTS, they are also SaaS. So you see a trend into the cloud now, finally erupting in the telco industry, which, as you can guess by the quite late move into SaaS, is a quite traditional industry. So how do we get to this journey? Our journey into microservices started not because of a technology consideration in that sense. We didn't go for microservices because we thought, hey, this is a great idea. We didn't go or select patterns based on them gaining a lot of traction. We have a problem and we seek a solution for that. And the problem that we had in the beginning, we didn't start out with microservices, was not a technology problem at all. It was an organizational problem. So we have our application, let's say our first version of our product, and it was as many applications at the time, a web application exposing web interfaces, built on a framework. Right, you start with a framework, Spring or Symfony if you're a PHP guy or whatever, and you build a bunch of modules to serve, to bring your functionality, to bring value to the business, to make your application do something. And then you'll need stuff, infrastructure around that. You'll need something to store data, right? Our first application used a relational database, like many applications do and still do. And then they'll use patterns, right? This was an MVC application, and we used ORM to interact with our data, with our domain, with our entities. You'll need some utilities around that at some point to improve performance or to improve scalability. You'll probably need a cache, or you might need a cache. There's a very distributed landscape of applications, as I just mentioned. So you talk to other applications a lot. You don't own everything. Talk to others, and sometimes it helps to do that queue-based already, a form of event-driven architecture. You need that to, for example, handle orders. Might be that the rate of ingestion of the orders in your system, might be different from the systems you're sending those orders to, and then a queue is very helpful. So you've built an application, and you start out with a small team, and life is good. It was a monolithic application, and there is absolutely nothing wrong with that, in my opinion. I think it's a good way to start an application, and that's what we did. And it was a modular monolith, right? So it was not like one big blob of code. There was logic to it. There were modules in it, extensions in it, plugins in it from the beginning. So it was modular, and you need that because if you start selling a product, you'll see that different customers will use it differently. And as the application grows, customers are interested in specific areas of your application. So also customers are all different, and as this is a very distributed landscape in terms of applications, you'll need to integrate with other applications. So you need a level of modularity, you need a level of, okay, this is my product, and this is my customization or my integration. You need to provide facilities for that. But as you start to grow, at some point you'll get a customer, hopefully, using your application. And you'll start to grow, and that customer, in our case, luckily for us, was very happy with our application. And then you'll start expanding your capacity. You start adding developers. You'll also start adding proxies. At some point, you might start very intimate with your customer. At some point, you'll add people like product managers or product owners. Two totally different things. I don't want to insult anyone. But you'll add a layer of proxies between your customer and your team. And at some point, you'll start adding more teams. And all those teams need to work on that same application. And that's fine. That's fine up until some point. we cut up our application in modules, right? So you could say that, okay, some teams, they focus on certain modules, other teams focus on other modules. More customers will come, more demand comes, more requirements come in, your backlog grows, you'll have to do more things, sometimes conflicting things. You'll have teams probably directly assigned to a customer. Different interests in terms of priority between teams will arise, and that's when the problem starts. Your teams might get in each other's way. So you could say, okay, some teams focus on some modules and other teams focus on other modules, and some other team focus on some other modules. But as you'll soon find, it's very hard to organically grow an application in a way that these modules are strictly separated. Of course, theoretically, it's possible. I mean, if you're the perfect architect and you have a window into the future and the perfect developers, I'm sure it can be done. But in practice, it doesn't happen that often. So some modules will be touched by multiple teams at the same time, and they all have different interests, and pressure will grow and they will have less time to talk to each other and align. And ideally, you have that strict split, right? So you have your teams working on certain areas, owning certain parts of the application. So you have a sense of ownership, you have a sense of, or you have a way of accountability, right? Who needs to solve what if it pops up? You want it to be very isolated, so less triage and alignment is needed between these teams. That is actually the problem that we needed to solve when we got into microservices. Not per se event-driven microservices, not per se event sourcing, CQRS, nothing of the sort, just as a first path into microservices, right? So what better way to enforce isolation than to introduce boundaries, right? Let's distribute this application. The term distributed monolith is used a lot, right? But we're splitting up our application and we're introducing boundaries that will force the teams to, well, think carefully of what they put where. And that makes it easier to manage. It also has some benefits. Theoretically, it could make the application easier to scale, but it could just as easily have the quite opposite effect, as we'll discover. So we'll split up our application into services, right? And usually that's the point also where we started, patching our user interfaces. When we go headless, it's also a term which is very popular now in commerce, mag. We go headless, and we have a bunch of services, serving our application. And then it's okay that these services, probably they'll start off sharing a database, and at some point you'll come to realize that that's also a point in the architecture where teams will trip over each other and have shared, will have conflicts in interest or make changes that others are not aware of, which will break functionality of others. So you want to separate as much as possible. At some point you come to the conclusion that it might be a good idea to also split up your data sources so teams don't get each other's way in schemas. So you'll do that, but you'll soon realize that, well, there's a reason this is one application, right? It's the reason these are not multiple applications. And that the modules, how well you define them, how well you model them using maybe domain-driven design or whatever technique you use, you'll come to the conclusion that data between these modules at some point, somewhere, will have to be shared. Otherwise, it wouldn't have made sense for this to be one application. It could just as well have been different applications from the beginning, and probably we didn't have the issues that got us into this way of thinking. So these services, just random pictures here, random blocks. Get used to them. I'm using them a lot in my slides. These modules, they need to talk to each other, and then a logical way to start is we've now split these things up. We've introduced a boundary, in our case, a network boundary. Right, that's quite a strong one in software. So these become individually deployable. That has its advantages in theory. They have a natural boundary in that I cannot just go into my piece of code and reference another piece of code. I need to go over the network. I'm conscious this is a boundary, but I need to talk to each other. So a logical thing to do is then to have one call the other. Right, that's That's okay. In some cases, that's a very good pattern to have. But more and more of these will start calling each other, right? And then you get into all kinds of different problems, because first of all, you detach them to begin with, and now you're tying them together again. Let's say on a softer level, less tightly coupled. And now with a well-defined interface, which we can be very conscious of, right? For example, Swagger schema, OpenAPI, or GraphQL, or SOAP, or whatever you're into. You have an interface, a schema, and that's kind of your agreement with the others, right? That's where the others, okay, this is how we agree to talk to each other, and when that changes, then we can add an element of backwards compatibility, or we can make strong organizational agreements on how we deal with that scenario. And it will not happen by accident. It will be very visible if something breaks there quite early in the process. That's good. But still, from an operational standpoint, that introduces some challenges, right? First of all, you need to manage all of this. We get into microservices and the inner and the outer architecture, right? Where we, in microservices, tend to move a lot of responsibility into the outer architecture. So we move the responsibility of safeguarding who can talk to what, for example, into a service mesh. We move the responsibility of observing what happens there into tools like Jaeger or the Elk stack or Grafana, right? Observability, we move it out. Also, we then need to think about what will happen if some of these things are not available, because they might, right? I am in my own piece, responsible for my own piece, and I'm dependent on something else which might or might not be available. And hopefully everything is available, but nothing in practice always goes right. Something will go down at some point. And then this pattern introduces a problem, right? And you can work around that problem. You can do stuff like circuit breaking and other ways to minimize the impact. But at the end of the day, you'll lose functionality. And in my industry, this is very relevant because this is a pattern you see. You see a lot in my industry. Systems calling each other. It used to be over in USB. And these days, some architects think that it needs to be API management, and then still use it in the same way. But they call each other. And if you look at what we do in our space, we do sales. We sell as products and services. And products break down. We call them product offers, and they break down into product, services, and resources. The stuff you need to connect on the network and the boxes you need to give the customer to make that work, which you bundle in something so it's tangible on a commercial level and has a price. And that's defined in, for example, a product catalog. And a product catalog tends to be one of these services. Let's say our product catalog is one service. Imagine. Those are the kind of services that tend to be called from a lot of other services all the time. Let's say I take this model, forget about hiding problems like circuit breaking and caching and other stuff. Imagine I have my app, my product detail page on an eShop. It needs to display a product I can buy. It needs to get that from the catalog. And then I add it to my basket. My basket probably will be another service, and my basket probably needs to know about products. Let's say I have a requirement that my basket will tell you if a product exists, yes or no. So I cannot add products which do not exist. And often a basket also is responsible for calculating prices. So it needs to know the prices. It's not a convenient basket if you allow everybody to set their own prices on their product. So also the basket needs to know about the catalog. And now we go into checkout, right? We go and buy that thing. And Taco, that's quite complex. I need to make, I might need to make appointments. I might need to make a porting, number porting, for example. I have my existing mobile number and I want to bring that with me into my new subscription if I'm buying one. I need to do credit vetting probably. If it's a postpaid subscription, then they'll check if you will be able to pay for that. Needs to do some fraud checks and all kinds of stuff needs to happen. And what needs to happen usually is dependent on which products you're buying. So again, this checkout part, let's say it's a separate service, it needs to know about the product catalog. And now we've made our order. We need to do our payment. Let's skip that one. At some point, it becomes an order, and the order has to be what we call orchestrated. Right? We have to break down this product offer, this commercial thing I'm buying, into products, services, and resources. And all those things will become orders again. we often talk about COM, commercial order management. We talk about SOM, service order management, and a lot of different kinds of TOM, technical order management. Different kinds of order management systems you'll find in a telco. And then often these products, because of the history of the telco, you'll see they'll have a lot of stacks. They'll have a stack for cable, they have a stack for mobile, they have a stack for IoT, and then usually also B2B and B2C are split up, and partner sales, MVNO dealers, all kinds of complexity and stuff happening with different systems. And that order needs to be broken down over all of that. And to do that, we need to know how this product offer is decomposed. And we prefer to configure that centrally in our product catalog. So our product managers can configure stuff and it will automatically work over the entire landscape. That's the ideal idea. So again, we have more stuff calling this product catalog. And as you'll see, we now have a separate team working on this product catalog, and they have a strong agreement with the outside world of how the product catalog works. To some extent, we've solved that problem of dependency there. But at runtime, they still need to call each other. They have temporal coupling. They all need to know where the product catalog is. If the product catalog is down, they will all not be able to function. If the product catalog is slow, they will all become slow. And as such, that is a danger in this pattern. Still, sometimes it's hard to go around this pattern, but there are some areas in some domain where it makes a lot of sense to start distributing information. So that's how we get into event streaming. Right? We start distributing some information between our services. Our services start sharing information with each other. Some probably will still call each other. I've never really seen a lot of domains or applications where you can completely avoid that. But you can now start spreading information. So one service will own information. It will let others know that something in that information changed. There are a lot of patterns. One of them we'll discuss in a bit, right? That's what this conference is about. But for one, you have CDC, for example, in the sense of change data capture, where you'll have a traditional application hook into its relational database, and then every change which happens, you publish it, and then others can listen to that. They can make reports out of that. They can, maybe as the BPMN system, they can do a little flow. Triggered on something with it which is happening there, and then we really go into event-driven architecture. But one application here is that I can spread information asynchronously. I can, for example, spread the fact that there is a new product which is launched, and then others might consume that information out of those event streams, or they might just be notified and then still do a call and fetch that information one time. There are many patterns possible here. And that is a convenient thing, because now I can spread information at the cost probably of data duplication. That's something that a lot of discussions with my customers revolve around. They are very allergic to data duplication. It's bad, right? Everything needs to be centralized, normalized, and it shouldn't be distributed. It shouldn't be duplicated. That's not a good thing for a lot of architects, in their opinion. But we do. We spread the information, and product information is an easy thing to spread. And now they will all, listen to their own piece of product information which they need, and slave that information locally so they can do with it what they want. Now they can act upon it if something changes and they need to do something, the saga thing or whatever. So that works well, and it adds an additional layer of decoupling. But still, we need to know how each other's events look like. They will still have a schema of a kind, and probably I need to serialize and deserialize this information. So there's still an element of a contract here, even though we removed the temporal aspect of it. And because there is an element of schema, there is also the aspect of versioning, which will come into play, right? What if my schema changes? And those are all very relevant considerations when we go into, let's say, our next logical step in our journey, when we go into event sourcing. So now in event sourcing, rather than having these events as a side effect, we'll use them as a source of truth. And this is a event sourcing conference. I'm not going to explain to you what event sourcing is, but a big difference with just event streaming is that we're now using our history of events, our stored version of events for decisioning. So we'll need to store them somewhere, all right? We can keep them on the message broker, if you use something like Kafka, but you'll have some challenges there, right? Kafka is very hard to query. And there are some more interesting alternatives out there these days, like Apache Pulsar, which kind of takes away that the complexity. Maybe I attach some kind of database to my message broker and start storing them there. Or more commonly, I'll have an event store with my service where I store this history of events, and I'll take a separate message broker, where I send these events to be consumed by others who can then create a projection out of that. We'll need to split up our service with CQRS, as probably all the others in this conference will let you know that event sourcing, great. We'll get into the pluses in a bit, but a big downside, of course, is the querying on your event store. It doesn't make sense to get every customer with the last name A and start instantiating all these customers in the event store, rebuilding them, dehydrating them, whatever, and then figuring out who in memory who of those has a last name that starts with an A. It doesn't work. It doesn't work at scale. It doesn't work for performance. So you'll add CQRS. You'll split up your service. You'll have your query services, your projections, whatever you want to call them, and store the data there. And you have the advantage of now, your write model and your read model not being one-on-one, so you can create multiple read models and stuff like this. So it's a next logical step. And internally, we had a lot of debate around this in the beginning. So when we started with event sourcing and CQRS, I had an architect colleague in my team who was an advocate of event sourcing, domain-driven design, and I didn't come from that train of thought. I never worked with that type of architecture before, and I was quite hesitant. Of course, I saw the advantages of this pattern, right? Everything has to be an event for it to even work, which means that events are no longer a side effect, which means that you have to be very conscious of those events. And you have to think about how you design those events. Also things that when you spread the data over the system, there's never a piece of data that you'll miss, because everything is an event for it to be even persisted, right? So that is a great thing. And you'll get an audit log for free. That's, in my world, enterprises. That's very important, right? Who did what when? Have a history, and you'll get all the data history, which is also great, right? You get the history of all data, so I can answer data needs in the future that I never knew I would have, right? That's also fantastic. You never miss any data. Of course, there are prices to pay for that, but in essence, that's all great, right? So then you start building with that. And I say, yes, okay, let's go for this. And I see domains, where there's a lot of transactional activity, where this makes sense to me. And it will force teams to, watch their boundaries, watch their contracts. I think that will work well. So we did. And the team started building their own library. Okay, right? It was a big framework versus library discussion, right? We don't want any magic, and we don't want anything bloated, and we don't want everything big. We're microservices now, so we need a library, not a framework. That discussion, and I left it to my team to make a decision. And they came out, we need a library, and they started building their own library. And that library, in a lot of my customers, is still in use today. And that's fine. Nothing wrong with that library. It worked very well. But as your organization starts growing, there's a lot of complexity that you've just added, right? You used to have an application which was one thing, one deployable, one database, 300 tables in it, I'll beat it. And now you have all these databases, and even within one service, you're splitting it up in different deployables, and you have libraries to manage and events flying around, and you get all the benefits that got us into this, but there are also a lot of considerations you have to think about when doing this, because in theory, this sounds nice, but to make it work in practice, and especially if you want to apply it everywhere in your domain, right? That was my architect's strong opinion on how to use this, right? Everything in our system had to be event sourced, and as such, use CQRS. So you get in a lot of pickles. And I want to go through these with you here. So you'll see more and more of these services moving into event sourcing rather than having events as a side effect. And one of the things you'll find is that working like this rather than in a traditional MVC or RAM application, it's a new way of thinking. Okay, you have to solve problems in a different way. And that's not easy for everybody to do. And of course, architects are very bright and smart people. That's why they are architects. I want to call developers here. But developers have been doing stuff in a certain way for a long time. And it's very hard to make that transition. And even for an architect, right? I don't want to insult people. It's even hard for an architect to make that transition in thinking. But also operations, right? So you now have these event stores and you have these streams going from left to right, and you have data stored in multiple places. Now, what if there's an inconsistency, right? We used to have everything in a single place, and we could, in a relational database, very easily visualize that, go in it, everybody understands SQL, do an update to a row, remove a row, and now we have this immutable event change, right? So what to do if something is broken? And you'll have heard from the experts in this in this conference that then you'll need to counter events and stuff like this. But for a simple operations guy, I'm using the word simple, but for most operations people, that is not, that's not very natural. So probably you already need an element of DevOps here, right? You need the people who built this to operate this, which in a product company, which is where I am, is very hard to do because there's an element of customers operating the system and they haven't built the system, so they were not part of that. So it's very hard to DevOps that at every customer, right? It's an on-premise model which we offer as well, and there are system integrators they used to be. I'm not part of one, but implementing this as well at customers. So that's for sure that is a consideration to take. So you need to do a lot of upskilling. You need to make sure that people understand these patterns and can work with these patterns. And there's also an element of making it. It will become harder to source people from the market to have knowledge on these patterns because simply, not everybody has. And there will be more people who have not than who have. Usually, they'll tend to be more expensive. Right? They are the people who have more experience. There's not a pattern you start off with in your Hello World 101. So that has some impact on your organization as well as a side effect. But also on the technical side, there's a lot of stuff that you have to think about. On the upside, the things that we set out to get are clear. You get less temporal coupling, you get your audit logs, you have your great insights in data, teams get more autonomy, and those are all obvious benefits that you get with this pattern, as others will also tell you. There's some other interesting applications that you can use it for, right? So for example, CQRS, we split up our read and our write side, and we have our dedicated query capabilities that we can build up our models and our technology choice and data store to suit our query need. But also in caching, for example, you can use this pattern to do interesting things. So if you have very high traffic on some services, let's say 10K TPS, 100K TPS and upwards, it becomes interesting to, on top of your data store, even if it's a very scalable, NoSQL thing or whatever database that scales very well horizontally. You might get an advantage in terms of latency, and you can save a lot on your resources if you apply caching there, especially on, of course, still data. So an interesting pattern that you can use is use a reverse proxy near the edge, caching reverse proxy, something like Varnish or the many other flavors there, which you can use to do caching of your stale data near the edge. So you reduce the latency towards your consumers. And the tough part in caching always is managing the state of the cache. You don't want information that's outdated to be served to your customers, or even if you distribute it over the world, let's say, to be inconsistent. So you can actively purge, flush, or however you want to call it, manage your cache, listening to these events, being notified that certain information changes, and If you design that well, you know very specifically which information is changing. You can do very precise purging of your cache stores, which can be distributed to achieve low latency and high throughput with less resources. And there are some other interesting side effects you can use this for, like versioning in our world. In inventories, products you have, there might be different versions of those products you get over time. Your inventory will have different versions. Documents will have different versions. Products will have different versions as they are designed. And because they have an explicit history of everything, you'll get benefits when you need to provide such capabilities in your application. There's also a lot that you have to be wary of. There's a lot of complexity introduced. And we'll go over some of these in the next part of this presentation. So there's a lot of problems as well. A lot of things you have to be very wary of. So look at, for example, the obvious. You're distributing your data. What if, for whatever reason, data goes out of sync in several places? Yes, you have a single source of truth. It shouldn't be a problem. Yes, you can replay stuff. But to be able to do that, you have to think carefully of how you implement stuff, especially if you're, like us in the beginning of our journey, we're using your own library and use generic infrastructure to implement these patterns. Scaling. Of course, yes, scaling is a big advantage of microservices and CQRS specifically. You can independently scale or very precisely scale parts of your system. But as you scale elements of your system horizontally, there are a lot of things to keep in mind, like idempotency, for example. If you want the capability to repair your data, or you want the capability to spin up multiple instances in multiple data stores, then your services need to be aware of which data they have consumed and which data they have not consumed. You have to be very careful when consuming data. What if you, for whatever unexpected reason, are unable to consume that data? What will you do to make sure you don't end up in an inconsistent state over the system? You'll also find that when using generic infrastructure, that infrastructure is not built for event sourcing. Like if you use a relational database as your event store, then you're probably using a single table to put your events in, and that table will grow, especially if your aggregates are very volatile, they change a lot, or if there are many of those aggregates, then that table will grow. And as you know, yes, it's a great thing that it's immutable, so everything is an append write. But if you change data, you have to get the current state of that data and decisioning if that state is allowed, yes or no, and then you need to fetch that data. And unfortunate side effect of these relational databases is that their indexes will grow, their tables will grow, and their performance will decrease. Message brokers, same story. Many flavors, many options there, but most of them warrant for a separated event store to be efficient because they are very hard to query and have some challenges if you use them for infinite data store. So also considerations to take there. There's some other problems that I want to highlight here as well. So the first one is obvious, right? We have a write model. We create multiple read models out of those by consuming these events, and we put that in different data stores. But what if, for whatever reason, and there could be many, something goes wrong? Something will go wrong. You might lose data. You might get inconsistent state. And then, yes, you can recover that because of your single source of truth, right? You can replay events. But that also means that whatever is consuming the data needs to know what it has consumed and where it was. And if there is a defect in your event handler and you're unable to handle an event, what happens then? And you need to take care of observability there as well. Operations needs to know that is going on. Same story for the eventual consistency, of course. Yes, it has the advantage that we're able to ingest data quickly and have some time to update our read stores, which also has a downside that it's not very evident for the consuming party. They need to take care of, need to handle the aspect of eventual consistency. But also on your service side, you need to take care that there is not a big latency or a big backlog of events to be consumed by an event handler, because that simply means that we'll have a problem somewhere. You need observability around that. All aspects you'll have to code and you'll have to build if you take an approach like we did with our own library, which takes a lot of time, and takes a lot of time to get right, and something will go wrong at some point in production, and then you get into the aspect of operations being new with these patterns and needing tooling to properly apply them. At some point, you'll come into situations where you do not own the data. At least that's the case for us. Sometimes we need to import data, and that could be through CDC processes where data is streamed. That's the ideal, but there are also cases where customers will use batch imports. And then what happens if those imports are inconsistent? Yes, that's not really a CQRS or event sourcing problem per se. That would be a problem in any pattern you use, but it creates some nasty side effects if you use event sourcing. For example, what if two data sources are inconsistent and the same aggregate, they are updating with different data every time that they are run? In a relational database in ORM, yeah, you'd still have the same row and it change values over time. That's fine. It's something you have to solve. But if you do event sourcing, you'll get a huge log of events, something which happened to us in some cases in the beginning. And then that event store will get very big, and then its performance will decrease, for example, if you're using a relational database. So these are also things you can't solve, but these are things you have to think about. And it's not something that, you'll immediately be apparent to you when you start with these things. When you're ingesting data at scale, you'll also have to, scale. You need to scale your consumers, and then you get into the problem that you'll have, one stream of events and multiple consumers. You get into competing consumers. You get into idempotency. You have to, again, take care of these things. And then as your event store grows, the issue of ingesting data when it changes your aggregate will come from the fact that you'll have a big event history and it will become expensive to dehydrate. And you'll get into things like snapshotting. You'll get into things like aggregate caching to solve that. So those are, again, additional complexities that you'll have to take care in whatever infrastructure is handling your implementation of event sourcing. So when you scale, for example, your replicas, you get into the competing consumer problem. You have to manage that they all process stuff in the same order and that they are able to cope with that. And again, that's a consideration you have to do implementations for, you have to do testing for, you have to keep testing, and that makes it expensive if you don't take any dedicated infrastructure, dedicated frameworks or libraries for that. If you all choose to do that yourself, then that becomes expensive over time. Some other problems you'll face as you're scaling out is that probably you'll need to have your application available in multiple availability zones, maybe in a cloud or multiple clouds or multiple data centers. You need to replicate data. And then if you've chosen your let's say, generic purpose data stores and message brokers, then this becomes another complexity. How do I make sure that the data is over sync over all of these availability zones and that I do not get conflicts, and how do I handle these conflicts? And this will become an additional complexity. And then there's an operations team who needs to manage all of that, right? So, of course, there are solutions for that, and this is one of the reasons why I'm speaking here on the Axonic event today. That's why we, at some point in our lifetime, made the switch from our own library into the Axon framework and Axon server. To handle this complexity for us, right? It implements both the function of your event store and your message broker or event router or whatever you want to call it in a single component which handles replication for you. And this is one of the big benefits that we got when switching from generic purpose infrastructure and our own library into Axon and Axon server. So concluding. This was supposed to be a very practical session about our story, our domain, how this is relevant to us. There are some takeaways that we've had over 4 years of event sourcing now on Axon framework and Axon server. Before on specifically we used to use MySQL as an event store and Kafka or RabbitMQ supported as a message broker. there's some learnings here, and I can say that event sourcing for us and CQRS, they are very useful patterns, and they've helped us achieve the goals that we set out when selecting them. We have a certain level of team autonomy. We have a level of scaling in the development organization, which we get as an effect of that. We have all the benefits for our customers. We can react on things happening in the world quite easily because there are events, it's distributed. There's a data history which gives us a lot of value. I mean, being in sales, being in customer information and interactions, and so much data in our world which we're able to leverage even before we know we have to. Auditing and versioning, very important concepts in the enterprise world, very valuable. And then, of course, the scalability aspects. Yes, when used right, this will increase runtime scalability as well as scalability of your development organization. And I can attest to these facts. However, we also had some learnings. CQRS and event sourcing comes at a cost of complexity. And complexity you have to manage. And then it all depends on, is this your core business? Is this a hobby project? At which scale do I do this? And what level of commercial support do I need on whatever I'm doing here? These are business critical applications in our world. And that is one of the main costs. So for us, one of our learnings was that, yes, building our own library was very flexible, meant very lightweight, and it worked very well. But it also meant we had to invest a lot in maintaining it and making it mature and dealing with the problems that you'll find. So as a learning for others, it would be my strong opinion if I were to do it again. I'd start with a framework which already has the learnings, which comes with training, so upskilling becomes easier. Maybe at some level certification or other assets which make it easier to source from the market. Let's say not as a developer, but as a CTO or CIO. I think these are very important aspects to consider. You need to bring the right tools. Yes, you can use generic purpose infrastructure, but there's a reason we, after 4 years, or it's not after 4 years we decided, but at some point decided to switch to Axon Server and Axon Framework and Axon Server Enterprise for our customers which do replication more recently. So bring the right tools, bring the right infrastructure. Yes, there is a lot of interesting generic purpose infrastructure, but it has its limits when you really are serious about applying event sourcing on a large scale. And as the number of moving parts increase, and this is not specific to event sourcing or CQRS, although very much applicable, microservices in general, the more you move into the outer architecture, the more you distribute, the more moving parts you have, the more difficult it will become to operate and maintain, and the more skills you'll need in that area, the more tools you need in that area, and things get more expensive. So choose wisely, right? Choose when you have an area where you need to be agile, where you need to incorporate changes quickly, where you need to scale. If these aspects are a thing, consider these patterns. If you have an application which will build and will barely change, if it has a very fixed type of workload, then it might be a good reason to look for different types of patterns in your architecture. And with that, I'll close my session. I said I'll be on the chat to answer your questions. Happy to answer any questions you take. Thank you very much for listening to me, and I hope to see you on the next conference in person. Thank you, guys. Bye-bye.